all that, let's go ahead and get Mark Scarpness up with Intel. I know Mark is here. I really appreciate this. Folks, the Internet of Things, maybe you've heard of IoT. Open source is changing and impacting IoT in a very big way, and Mark is here with Intel to tell us about that. Mark, thank you for being here. I appreciate that.
Thank you. Thank you very much. It's a pleasure to be here. And I'm excited to have the opportunity today to talk about the critical role that open source can play in creating the world of the Internet of Things. I believe that the Internet of Things has the potential to change the world and to change it in profound and meaningful ways. You know, IoT is certainly one of the hot topics of today, gets a lot of coverage, gets a lot of hype. And maybe some of the examples of IoT devices that you've seen have looked a bit trivial. I remember being at the Consumer Electronics Show earlier this year. There were a lot of IoT devices being shown and seeing, connected refrigerators that had cameras inside of them, that had screens on them. And maybe those aren't going to change the world. They're cool products. But those examples do exist. And they exist across a wide range of industries and applications: smart cities, smart grid, automotive, connected home, healthcare. There really are examples that have that potential. But with that potential comes some really significant challenges for us in the open source community to work to address. One of the big challenges that we have coming is a whole new group of developers. Developers that have great ideas for applications, for devices that they want to build, but who are not embedded systems experts. And we have, in the open source community, created a great set of technology building blocks and tools, but we need to help bridge the gap between this new group of developers with great ideas and this great set of technology that we've created. We need to help connect those two together. Another challenge that we have with IoT is a new set of requirements. Take, for example, security. There have been, and you've probably seen this, already a number of examples of IoT devices being hacked, people's personal information being stolen. We need to do more to help these new developers build truly secure devices. Because we're going to have IoT devices that have access to our personal information, that might be controlling physical infrastructure, access to our homes, our roads. And if these IoT devices aren't secure, if they're not trusted, they're never going to be deployed. We have to do more to solve that problem. Another key area of new requirement is around communications. IoT devices at their core are gathering data with sensors, they're doing computation, and they're sharing that data. They're sharing it with each other, they're sharing it with the cloud, and there's a whole new set of requirements that we need to work on together around communications. One of the examples that has this world-changing potential, I think, is around vaccines. If you think about vaccine production, I'd never really thought about this. It turns out that vaccines are very sensitive to temperature. So vaccines have to be kept at a controlled temperature all the way through the distribution chain, from the factory that's producing them through the whole distribution network out to the clinic where they're given to the patient. And if you imagine trying to do that in a developing country, it's really, really hard to make sure that that vaccine is kept at the right temperature all the way through that chain. And in fact, in some developing countries, up to 30% of the vaccines are spoiled by the time they reach the patient. But what's even worse is there's no easy way to know. So patients are given vaccines that aren't going to work. So we've been doing some work with putting sensors on vaccines, actually taking a little IoT device and sticking it onto the smallest unit of packaging for that vaccine, so that all the way through the distribution chain we can track the temperature and report that data back. And if the temperature is falling out of the desired range, you can take action. Or at the very least, when the vaccine shows up at the clinic, you will know, was this vaccine kept at the right temperature? And if not, you can throw it away and use a batch that's actually good. Just think about the impact that that will have, the millions of lives that can be changed by getting the right vaccine, the one that's actually going to work, just by using a simple IoT device. Another example that I think is very exciting and promising is around drones. There's been a lot of work in the open source community to create drone stacks and drone code and other projects. And they've also been looking at how can they use drones for humanitarian efforts. For example, in search and rescue. Or imagine if there's a natural disaster, sending drones out that can do reconnaissance, look at where the damage has happened, and send the aid to the right places. So just a couple of examples of how IoT can really have a world-changing impact. But we need to do more to help people build these devices. So what do we have today? If you think about the place that you would start if you're building a device today, you kind of have a couple of choices. You can take an existing, say, open source solution and you can modify it. If you're building a Linux-based device, you could take an existing Linux distribution, take out what you don't need, put in things that are unique to your application, build that into your device software. That's one place you could start. We at Intel have been working with the open source community on the Yocto project, which is a very powerful tool for creating custom embedded Linux images. So it allows you to take, again, this great set of open source building blocks, the kernel and communications components and sensor drivers, integrate that all together and create your custom device software. So some very powerful starting points, but they do require you to be an embedded systems developer. You need to have a lot of system knowledge to do that. So we need to take this as our foundation, and we need to do work together to bring the new capabilities that are going to be necessary to create the world of IoT. And I think of that in sort of four broad categories. I talked about the need for security. We already have a lot of security building blocks in open source, which is great. But creating a secure system, as is evidenced by the fact that people are building these devices and they're not secure today. They're not doing that because they don't care. In many cases, they're doing that because it's really, really hard to do. You have to be a security expert, you have to be a systems expert to take these building blocks and build them into a secure device. We need to do more together to take those building blocks and provide them at a higher level of integration, to sort of provide a foundational set of secure platform building blocks that can be used to create these devices, putting things together in the right way so that this new generation of developers can build secure devices without having to become embedded systems and security experts, because that will never scale. We're talking about a world of 50 or 100 billion devices. There's going to be millions of new developers, and we have to help them bridge the gap, use our technology, and build secure systems. And something that goes very much hand in hand with that is device management, and particularly update. If you think about what does it take to build a secure system, you need to start with a secure foundation, build a secure device, and you have to be able to update it. Nobody's going to build perfect software. There's new security vulnerabilities found all the time. And if you can't update your system, then you're fundamentally going to be broken. And this is, certainly a solved problem at a bigger system size. There's lots of known ways to do that. But if you go down to the really small devices, like think this vaccine sensor, a lot of those devices historically have been built without the ability to be updated. And I've been talking about this, people have said to me, well, hey, this is a cheap little device. If it has a security flaw, I'll just throw it away. I'll get a new one. But that doesn't work. Imagine that you're at home and you've embedded sensors in the walls of your house, or you've embedded sensors into the pavement on the roads, or into the infrastructure in your office building. You can't take those out. You have to be able to update them. So we really have to think about this problem across the whole spectrum of device sizes and capabilities. We've got to be able to do update, and we have to help the people building these devices to do that update because otherwise they're not going to have secure devices. Customization. One of the other really interesting things about IoT, I think, is the incredible diversity of that market. When we say IoT, people tend to think about their connected home, which is certainly an interesting example. But there's many, many other applications and markets. Think about automotive and healthcare and industrial automation, really, really different from each other. We cannot just create one software stack and say, okay, the problem is solved, here's your IoT software stack. This is very different than like smartphones, where a stack like Android can really become the predominant software stack for most of the world's smartphones. I really do not believe that's going to happen in IoT. The diversity of usages and devices is just too wide. So we need to provide this higher level of building blocks that solve some of the hard problems like security, but we need to provide those in a way that the developer can plug them together in different ways and provide them a mechanism for customization. But again, not the low-level sort of embedded systems customization. It needs to be taken a level up so that they can actually take advantage of the technology we're building. And then finally, connectivity. IoT devices are all about communicating. And there are lots of new communication protocols that are coming. There's Thread, there's Bluetooth Low Energy, there's Bluetooth Mesh in the home. And again, across the breadth of IoT, there are many other technologies. That's one area we need to continue working on. But there's a new requirement. I don't know if you've had this experience. I was out looking at smart light bulbs and light switches, and you have to pay attention to which vendor you're buying from. Which is kind of a weird experience. I always thought about, I buy a light bulb, I buy a light switch, and they'll work together. That's kind of the normal consumer expectation. That's not true with smart light bulbs today. If you don't buy them from the same vendor, they might not work together. And that is a problem we have to solve. How do you enable devices to talk to each other and interoperate with each other securely across vendors? So about a year ago, we at Intel, together with some industry partners, started a group called the Open Internet Consortium that's focused on solving this problem. And basically what we're doing in OIC is creating a written specification that describes how devices talk to each other. And then OIC is sponsoring an open source project, IoTivity, which is hosted at the Linux Foundation, where we're doing the reference implementation of the spec. And then finally, OIC is doing certification. So once products are built containing the code, they can be tested with each other to ensure they interoperate. So kind of the three legs of the stool are specification, implementation, certification. And we're actually just released the 1.0 spec and the 1.0 code for OIC and IoTivity, and you'll see those first products coming to market this year. But that's, I think, a really critical part of creating a broad world of IoT devices. You have to have standards, you have to have interoperability. Otherwise, these devices are not going to work the way that users expect. So what's our ask of you? We have a booth downstairs and encourage you to go check that out. We'll be showing off some of the technologies that I mentioned. We have a nice demo of OIC that you can see in action. I'm also going to be talking later today and going into a lot more detail, particularly on the communications piece. So if you'd like to hear more about that and about OIC and IoTivity, I invite you to join me at 2:30. I'll be doing that. But most importantly, I want to invite you all to work together with us and everyone in the open source community to really work on solving these challenges. We've got some really great technology building blocks, but we have this new set of developers, and we have these new requirements. We need to take our technology and bring it to this new audience. That is how we can really make open source the foundation for this new world of the Internet of Things. So with that, thank you all very much.